So now let's take a look at this one here. What is this? R equals 4. Well, if we just think about that, R equals 4. Okay, so the radius is 4 out here. And all along here, radius is still 4, radius is still 4, radius is still 4, all the way around. Yep, that's a circle. Okay, and what's the radius? 4. Now, wait a minute, why doesn't it change or anything? Notice in the equation, there's no theta. So no matter what theta you are, what's R? 4, always. Okay, by the way, where's the center? Is at 0, 0. Or 0, whatever. The pole, the origin is the center of it. Okay, so let's take a look at this one here. 4 sine theta. What does that look like? Well, if I take a peek over here, and at Edmodo, here it is. At Desmos, here it is. Okay, so here is that we have the a to be 4. So that's 4 sine theta. That's a circle. What symmetry? In other words, along which axis? The y. Now, how far? What is that radius? How far up is it? Yeah, just 4. Now, when you think about it, makes sense. We'll go back to the graph here. So we are at the origin. We'll go up 1, 2, 3, 4. Now, why does that seem to make sense? Well, what is r at 90 degrees? So 4 times the sine of 90, or 4 times 1, 4. And so this is a circle looking like this. Now you might say, wait a minute, what about 270? Okay, plug in 270. So that's 4 times -1, or the sine of 270. So 270, -4, bing, up here. Actually, it turns out that we only need half of a full rotation to get that circle. So again, because of the sine, we have the y-axis symmetry. Radius is 2 this time. This time, notice the center of this is at 0, 2. That's a more rectangular coordinate, but the center is on the y-axis. So if we think about what we would just been working on with limasones, how about this one? Where do you think that's going to go? What kind of symmetry? Yep. So if we do what we just did before, so let's plug in 0. Cosine of 0, -3 times 1. And then, of course, the origin. Now you might say, wait a minute, why the origin? Well, think about what happens when the graph or the angle is at 90 or 270. Cosine is 0, so r is 0. So we have this circle here. Now you might say, wait, okay, this time the radius is -3/2. Oops, not -3/2, just 3/2, 1.5. Again, radius is, how big is that? Because from 0 to 3 is your diameter, like up here, 0 to 4, that's a 4 for the diameter, radius. Diameter is 3, what's the radius? Exactly, okay. And that center is on the x-axis. Now, we really don't have to go that deep into actually plugging points because, again, taking a look at this a, that coefficient, and look at where that point is. We know it's what sign? Y, with a positive 4 for the a. Notice where we're at. Okay, so let's go get them all together. So centered at the origin, that's the r equals a value. Doesn't matter what the value is, positive or negative, doesn't matter. Centered at the on the x-axis, r is a cosine theta, and then the y, a sine theta. Just so we tie the two together. So when it's centered at the origin, the actual radius of the circle is a. When it's centered on the x-axis or the y-axis, the radius of the actual circle you draw is a over 2. Oops, wrong page. Okay, and let's go ahead with, ooh, there's no numbers, no trig. This is strange. This is a strange one. This is a spiral. Actually, you may actually see this saying the spiral of Archimedes. Okay, you know, the guy who dealt with volume and displacement in the bathtub. Yeah, I'll let you deal with that, Saints. So there's no nice good way to do this other than plugging in a set of points. What points? Well, we're going to use the 5 axes. I say, wait, 5 axes, yes. 0, 90, 180, 270, and back to 360. However, I'm not going to use 0 or 9. I'm not going to use degrees. Why not? Because think about it. Even though I'm going to write this, put this here, I'm going to still write it as the ordered pair. Because at 0, 0. But at 90, the radius is 90? That's way too big on the graph. So let's focus. Let's zip back to, or not focus, let's use radians. Because pi over 2, well, if r is equal to theta, pi over 2, then we get an approximation of 1.6. That's close enough. So 0, 0, pi over 2, and so 1.6 comma pi over 2. 1.6 in the direction of pi over 2. At pi, yeah, we know what that is, 3.1. So pi direction, 1, 2, 3.1. Again, don't worry about it if these are so small. Don't worry if you're going a little bit over one way or another. So 3 pi over 2, well, that's going to be about 4.7. So, and 3 pi over 2, 1, 2, 3, 4.7, oh, pretty close to about there. And to complete it around 2 pi, again, all I'm doing is punching this into a calculator. So 2 pi is 6.28, so about 6.3-ish. So here's 2 pi, the same as 0. So 6.28 is about there. A little bit beyond, that's okay. Now, how do you connect those? Well, connect them in order of the angles. Here's the 0, pi over 2, pi, 3 pi over 2, 2 pi. So when we see spirals, we're going to have to make sure that we use radians, because they just get to be too big if we try to use degrees. So we use radians on those, okay? So again, with spirals, there's nothing to do except for plug in those nice values. Again, that's the angles on the axes in one revolution, okay? Try them, see what you get, and we'll work through it later.